Hello, we are working on section 2.1 today, and I'm going to focus on day 2. This, however, the screen that you're looking at right now was the day 1 homework that we did during class from page 103. Here are the answers that I had. See how those match up with what you came up with. If you had any questions on these odd ones, you could go to calcchat.com and look at their details of the work that they show. So I'm going to go ahead and move on. Hit pause if you need it longer. So we're on day 2, looking at writing the equation of a tangent line. I'll show you how to use the graphing calculator to use the derived function from the calculator to get a numeric number. And then let's determine if functions are differentiable and what does that mean. So first off, writing the equation of the tangent line. To write an equation, we need two things. One thing that we need is a point, some x comma y value that falls on the line. The second thing we need is a slope. If we have those two items, it makes writing the equation of a linear function quite easy. I like this point slope form. Y minus y1 equals m times x minus x sub 1, where we're using the point that we're putting in is this x1 comma y sub 1 point. Next thing I have here is we're going to use that definition of a limit. Okay, as I was saying, I got interrupted. The definition of derivative will be what we use to find the slope, and that's going to be this formal definition. So let's just go in and do a problem here. Write the equation of the tangent line. So let's find the equation, which means that first off, one thing I definitely need is the point. Let's find that first. That's the easy part. Okay, when x is 2, I'm going to evaluate this function at 2, which means simply plug in 2 everywhere I see an x. 2 cubed minus 2 squared plus 1 gives us 8 minus 4 plus 1, and that turns out to be 5. That gives us then this point at 2 comma 5. So that's cool. We needed that. Hang on to that. Next thing we need is the slope, and this is where it's going to get fun. The slope, we're going to use that limit definition as as h goes to 0 of f of x plus h minus f of x divided by h. This will give us the derivative of the function, also the slope. All right. For this function, I am going to, here's our slope calculation, the limit, or f prime of x equals the limit as h goes to 0. F of x plus h, I'm evaluating at x plus h. So everywhere I see an x, I'm going to replace that x with x plus h. Here we go. X plus h gets cubed. Onto the middle term, minus. Something's getting squared. I'm evaluating at x plus h, so I put in x plus h. Final thing, I have that plus 1. Don't forget that. Minus. The next one now I'm focused on is f evaluated at x. Notice how this is f evaluated at x, so I just need to copy that. The minus will be changing everybody's sign then. So I'm just going to flip my signs right now. So I'm coming in with a negative, a positive, and a negative because I'm doing a minus f of x. Okay, we got that all over h. Do you remember how to cube something out? Hopefully you do. I'm going to do a little work off to the side. See if you can recall doing Pascal's triangle. Pascal's triangle starts out with a 1, 1, goes to a 1, 2, 1, and the third degree here will be a 1, 3, 3, 1. This will take us up to a cubic. Do you remember that these represent the coefficients of each of the terms in our expansion of this cube. So I will have 1 x cubed plus 3 x squared h plus 3, coming from the coefficient, 3x h squared plus 1 h. I'm sorry, h cubed. Got it. Where did all that come from? Well, if you recall from Pascal's triangle, something that you worked on in advanced algebra, I start with my highest degree, and the x value is going to go 3, 2, 1, and then x at 0, or 0 degree, which makes it 1. Then my h's, this really has an h raised to the 0 power, but we know that is just 1. And then it goes 0, 1, 2, 3, and that second variable is climbing in its degrees. So now that we've got that expanded, I'm going to come back over to my limit and write that down. So x plus h cubed becomes x cubed plus 3x squared h plus 3x h squared plus h cubed, and that's the expansion for the cubing one. If you did not like what we did here for Pascal's triangle, you could always go back to the trusty method of writing down 3 of those factors and then proceed by foiling. X squared plus 2xh plus h squared. Then I'll take that and multiply it by this last one and run that through. We should get the same exact answer that I just gave you. So that's another method. If you'd rather do it that way, go for it. Now, the next one I need to expand is minus. Minus all this squared term. So squaring x plus h is like taking x plus h times x plus h. Gives me an x squared plus a 2xh plus an h squared. Finally, I will add 1, because it's right there. Don't forget that one. Minus x cubed plus x squared minus 1 all over h. All right, so we have this down. Now we've got the hard part done. Let's just simplify. And, oh, you know what I need to do? I need to run that negative through. I'm going to rewrite all this. I know it's a lot of extra work, but it will keep my work nice and clean and accurate. So I'm taking that negative sign and I'm passing it through the pink parentheses. And that is all I'm accomplishing with this particular line, because now I have a nice clean work that I can look for things that add together. And I have a positive x cubed with a negative x cubed, a negative x squared with a positive x squared, a positive 1 with a negative 1. Let's summarize what we have remaining. The limit as h goes to 0. I am left with a 3x squared h plus a 3x h squared plus an h cubed, a minus 2xh and a minus h squared, which is fantastic because they all have an h in them. Each of those 5 terms have an h in them, which allows us to do a GCF and bring that h forward, canceling with the bottom h. So let's pull that h from everything. Leaves us 3x squared plus a 3xh plus an h squared minus a 2x minus an h. We pulled an h, didn't we? All over h. Our h's are going to cancel, which is wonderful. Now, using substitution, I can put h at 0 to solve this limit. So using substitution, put 0 in for h, and I'm going to end up with 3x squared. If I put a 0 in for this one, it removes the term, taking it to 0. This becomes 0, it's gone, and this becomes 0, so no impact from that term. I end up with 3x squared minus 2x. After all that work, what does this represent? Well, if you look way up to the beginning where we started, we said f prime of x, the derivative is equal to 3x squared minus 2x. You just found the derivative of your problem. Now, what we need to do is evaluate this at the point, scroll back up, at the point of 2. So, notice how this is a function. Function evaluated at x. Now I want to take my derivative function evaluated at 2, and I'm going to have 3 times 2 squared minus 2 times 2. That turns out to be 4 times 3 is 12 minus 4. We have a slope of 8. F prime at the point 2 gives us a slope of 8. Let's just write that beside it. This is our slope. To write the equation of the tangent line, we are going back to that y minus y1 equals m times x minus x sub 1, and I put in my numbers. Remember the point, look up on top, we had the point at 2, 5. We had already calculated that. So I'm going to have y minus 5 equals 8 times x minus 2. Our point was at 2, 5. Fantastic. A very long problem, isn't it? It said use a calculator to graph the function and its tangent line at the point. So grab your calculator and let's... Okay, I took a break here and I got my calculator set for you. Hopefully you've done the same. Let's put in y sub 1. I put in x cubed minus x squared plus 1. And then I took, while I was on break here, I took and transformed the point slope form into slope intercept form. Y equals 8x plus 11, so that I could put that in my calculator as well. So my original function, the cubic, is in blue and the linear is in red. If I hit graph, we're going to see those two functions. And indeed, we have a tangent point at 2, 5, and the red shows the tangent line. Yes, that works good. All right, this would be another long problem, and I'm thinking that maybe we should just do that when we get back to class. Or, you know what, let's make it homework for you. Please have that done. That's your objective for the weekend. You watch this video and I want you to go in and do that. It already gives you the point that you're working with, so you don't have to plug in 5. If you do, you're going to get 2. So it gives you the point. What you need to figure out next is the slope, right? Go in and use that formal definition of derivative. F prime of x is equal to, and I'm going to help you get this set up. We want to evaluate it at x plus h. So everywhere I see an x, I'm inserting x plus h. So I have the square root of x plus h minus 1. And then add to that, subtract from that, the square root of x minus 1 all over h. And I need the limit as h goes to 0 for this whole process, and we should be good. How do you solve that? My suggestion is take this thing and multiply it by the conjugate. And the conjugate will have a plus sign instead of that minus sign. So this should help get you started. And then once you get the top multiplied and the bottom multiplied, try plugging in 0 so that we let h goes to 0, and you should get your answer. And then evaluate. Once you get your derivative, evaluate it at 5. See you on Monday.